Okay, I guess I have upload these notes, okay, in the e-learning, okay. Discuss on the method of slices based on Dr. Kamaruddin reference book, okay. So a little bit explanation on the method of slices, okay. The same approach with the total stress, okay, where we use the resting moment over driving moment, okay. So in this explanation, the most important thing is to determine the alpha, okay. Then the from the alpha we can get the value for the length of the base of the slice. Okay. Okay, so the equation that we have derived, okay, based on the Fillenius approach, okay, uh, is refer to this equation, okay, where we have a CL uh, plus W cos alpha minus UL times tangent phi over W sin alpha for the driving moment. Okay. So from there, we may uh, look on the notations for each equation. Okay. So we have here C, okay, which is the C is equal to cohesion. Okay. Then L is the length of the base. Okay. So for the length of the base of the slice, okay, is equal to B width of the foundation, width of the slice over cos alpha. Okay. So then we have here P, which is the normal force acting on the base of the slice. Okay. So when we translate into the alpha value, so it becomes W cos alpha. Okay. So then we have the pore water pressure. Okay. So the rest is same where we use the alpha and also the P value. Okay. So that is for the Fillenius. Okay. So while for the Bishop, okay, so this is the equation. Okay. Uh, where the CB, okay, similar with the explanation in the Fillenius. Okay, however, the difference is they have the M alpha. Okay. So since Fs appear on both sides of the equation, trial and error procedure need to be performed to determine the factor safety value, as I mentioned previously based on the slide. Okay. So we go for only two examples based on Dr. Kamaruddin. I guess this is the most comprehensive example. Okay. Uh, if I'm compared to any other reference book. Okay. So it's very easy to understand. Okay. Okay. For the figure, okay, this figure 2. Okay. Sorry. Okay. For the figure 2, okay, show a slope with assumed failure surface. If Fillenius method based on effective size is used to analyze the slope, consider slides 3 and 6 and fill the accompanying table. Assume the groundwater table is far below the slope surface. Okay. So this is the soil properties. Okay. The slope consists of two types of soil, which is soil number 1 and soil number 2. Okay. So okay. Hope you can see this image. Okay. So that's why it's very important to plot the problems on the grid paper, okay? Because you can get we can determine the height and also the width of the slice. Okay. Okay, let me draw something. Okay. So for example, to begin with, okay, So the first thing is we need to determine the what we call as the B value. Okay. So for example, for slice number 3, okay. So we draw a line here, okay. Or we can count the number of the box, okay, which is for every box, okay. For example, 5 box represent equal to 10 meter. So it means that for every box, it represent 2 meter in the width or in the height. Okay. So for this case, this size number 3 contains 1, 2, 3, 4, 5. Okay. So 5 box. So the width is equal to 10. Okay. Okay, so the width is equal to 10. Okay, for size number 3. Okay. Then from when we divide 10 into 2, it will become 5. So then we need to draw a vertical center line. Okay. Okay. So then we may determine what is the height for the first soil and what is the height for the second soil. Okay. So we need to count, for example, for the height for the first soil. So it be written here as 8. So means that it has 4 boxes. Okay. While for the height for the second soil, for the slice number 2, it is equivalent to 12. Okay. So based on the center, so we use a long ruler, okay, and then it should intersect the 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 center at the base, okay, in order to obtain the alpha value. Okay, so use the protector, okay, and then determine the alpha value. So this alpha is equal to 10. Okay, so as I told you before, okay, this side from the origin, we can consider as, for example, negative. We will look for the solution data. So while this side on the right we consider as positive. Okay. Okay. So that is for the important value. Okay. So the rest we may use the equation to solve it. Okay. So we look on the solution. Okay. So that's why I told you this example is easy to understand. Okay. So first, Dr. Kamaluddin show how to determine the W. Okay. So the W 18 times 10 times 8 for the first layer, 19.5 times 10 times 12 for the second layer. So the value is equal to 3780. Okay. So Dr. Kamaluddin use negative for the left side. Okay. So 3780 times sign negative 10, so it will become negative. Okay. So that is for the W sine alpha. Okay. So we need to solve the problems for the whole what we call for the whole equation. Okay. By separately for example, solve first the either this driving moment and then solve this resisting moment on for example, this is we solve it first, then continue with this second, and then this will be the third. It depends, okay? Which one is easy to solve first. Okay. For example, Dr. Kamaluddin solved the driving moment, okay, and then he solved the sub-equation for the resisting moment. Okay. So CB over cos alpha, then he obtained 355.4. Okay, then he solved the problem, okay, for the sub equation for the resisting moment. Okay, so then the other sub equation is equal to 2149.23. Okay. Okay. So that is for the slice number 3. Okay. Then for the slice number 6, okay. So this is the table for slice number 6. Okay. Then the width is equal to 10. 26 is the height for the H1 and 4 is the height for the H2. Okay. So this is slice number 6. Okay. So the width is equal to 10. The width is equal to 10. Okay. So then get the center line. Okay. Then we may count in terms of the value for the soil number 1 and the soil number 2. Okay. Then determine the phi value. Okay. In this case, the phi value is equal to 37 and it is positive. Okay. So the 37 is the positive value. Okay. So this is the positive. Okay. So Dr. Kamaruddin solved first the driving moment. Okay. And then the resisting moment for the sub equation number 1. Then repeat with the sub equation number 2. Okay. Take note that the strength parameters C and Phi used in the calculation are those at the base of the respective slice. The negative angle value indicate the position of the slice in the resisting slide. Similar process are to be undertaken on the other slice to obtain the overall safety of the slope with the trial failure surface. Okay. Okay. So to get the whole value, okay, for this problem in terms of factor safety, so you need to solve the slice number 1 until slice number 7. Okay, from there you need to get the total value for the resisting moment and then the total value for the driving moment. So you need to divide resisting moment over driving moment. But at the same time, they are root on the slice number 4. Okay. So you may include this width of the road, okay, in the driving moment. Okay. So you need to find what is the typical width of a road. Okay. For example, if the road made from the concrete, so the width or unit weight of the concrete is equal to 24. Okay. So 24 times 6 or times 8. Okay, times 8 okay, is the load. Okay, is the stress. Okay. And then to get the moment arm, 2 plus 4 is the moment arm. Okay. But you need to make sure that the units that you obtain is similar with the unit for the driving moment from the calculation. Okay. So then you may include this road with the calculation of the driving moment, which is W sine alpha. Then that is the driving moment occur, okay, in these problems. Okay. So as I told you previously, okay, where the soil how about the traffic? Traffic doesn't count because traffic is not a permanent. Traffic is not a permanent value load. Okay. So this soil at the base only covers soil number 1, okay, while the rest is covered for the soil number 2. Okay. So this is the one of the important things need to consider. Okay, when you want to draw the slice, make sure that at the base only cover one type of soil. Okay. Yeah. When then later on we look on the it's very difficult to understand compared to this example. So it's or you can look on any other reference book, it's difficult to understand. Okay. Okay. So this will be another example. Okay. Before we move to Dr. Noli example. Okay. So Fillenius method on effective stress. Then we try to calculate based on the Bishop method. Okay. So for this case, the soil uh, for this example only cover for one type of soil only. However, due to the seepage or due to the poor water, due to groundwater level, okay, the property soil change, okay, where the soil above the groundwater table is given by this value and the soil below is given by this value, okay. So we need to count for the height of the water, okay. Okay. Okay, for example, okay, a little bit different to explain because Dr. Kamarudin used a flow net approach, okay. Because in other in normal textbook, okay, so they only consider the height of the groundwater only. Okay. For example, if this is the groundwater table, okay, so it doesn't require for us to draw for the flow net. Okay. So if we want to determine the height of the water, so we just draw up to the groundwater level. Okay, for this case, if we are referring to Dr. Kamarudin, so he used the flow net approach, then the height of the water level is HW. I mean the HW is less than the groundwater level. Okay, but in this case, we just refer to the HW equivalent to the height of the develop of pore water pressure by using the flow net approach. Okay, but if you want to solve the problem related to the pore water pressure, okay, so it will be fine to determine the height of the water up to the groundwater level without construct the pore water pressure by referring to the flow net approach. So you just simply get the HW, okay, from the base to the groundwater level. Okay. So for this case, okay, just draw the but for this example, you need to refer to Dr. Kamarudin. But if you have any related problem with the groundwater level, just draw up to the groundwater level, which is equivalent to HW. Okay. Okay. So this is for the Fillenius. Okay. We repeat the same procedure with the previous one. Okay. So we determine the Wn. Okay. Then from the W, okay, this is for the slide number 3. Okay. So actually N is referred to 3, okay, which is the slide number 3. Okay. So from the W, solve the problem related to the driving moment. Okay. Then determine the sub-equation for the resisting moment, okay, which is the CL. Okay. So for the P, which is the sub-equation for the resisting moment, okay. Solve first for the P, okay, and then determine the pore water pressure, okay, which is the U time with the what we call as the length of the base. Okay. So since CPS is considered, the pressure heat HW is less than the depth of water, measured from the base of the slice due to dissipate in energy. It could be illustrated by drawing a flow net. Okay, refer to the slope diagram. Okay, so if we are referring to Dr. Kamaruddin, okay, we need to refer to the height of the pressure head, which W. Okay, so the W of the phi represent the internal shear surface under the consideration. Okay, so then this is the what we call as the resisting moment uh, for the slice number 3. Okay, so the above steps are repeated for the other slice in order to complete the table to obtain the overall safety factor. The tabulated value are shown in table 1. Okay, the factor safety is obtained by dividing the summation of resisting force in the column 13 by the summation of driving force in the column of 8. Okay, so then to solve the factor safety value, we need to count uh, up to slice number 9. Okay, so this is the driving moment. Okay, while this is the resisting moment. So resisting moment divide with the driving moment. So we obtain 0.95. Okay. That is the Arrhenius. Okay. Yes. Okay. So if we have more slice, so actually we have a more accurate value. Okay. Because we have the same with the final element. The small mesh, the most accurate value, but it consumes a lot of time, okay, to solve uh, this this problem when we increase the number of the slice. Okay. Okay. We can use 4 slice, okay, but later on, okay, we can look on the factor safety value. I guess we will have a higher factor safety value, okay, because as an engineer, we may use the conventional value, which is the less is better. Okay. So then for the bishop, okay, the same procedure, okay, and then put on the, because how to retain, okay, the most optimum point of 0, okay, as I told you, the origin point of origin, as I told you previously, we may refer to the chart that I have discussed in our previous class. Okay, so from there, we calculate first the factor safety, and then we try to relocate the point, okay, and get the factor safety value until we obtain the most lowest value for the factor safety. So that we can consider as the most optimal location for the point of origin. Okay. Okay, it's very tedious if you want to determine the factor safety, okay, manually. Okay, for example, for this case, this is the point of origin. Then we need to change the location here. Okay, then slightly on the left, on the right, down, above. You just imagine slope W can run less than. Okay, so slope W is the best because slope W can run 2000 analysis. Okay? 2000 analysis, less than 1 minute. Okay, for us, we take about 1 or 2 hours okay, to run for only to calculate for one problems. Okay. Okay. Yeah. My answer is 1.5. Your answer is 1.5, and my answer is 1.2. Okay. Oh, it's okay. It's okay. Okay. There will be a yeah, plus minus. Plus minus. in terms of the factor safety value. Don't worry about that. As long it's not uh, very too far from the uh, from the from the scheme. Okay. Okay. So okay. Okay. So it's more tedious. Okay. This is more tedious compared to the villainous. Okay. Yes. Yeah. As long you use the procedure is you use the procedure is correct. Okay. You use the formula and the correct procedure, so you'll be fine. Okay. So this is more tedious. Okay. Based on the bishop, where we need to first, okay, assume the factor safety on the left, on the right, 1.1, and then we gain the value 1.14. Okay. Then Dr. Kamarudin increased 1.3. Okay. Then he obtained 1.16. Then he increased 1.5. Okay. Then he obtained 1.16. 1.18, sorry. Okay. The same where we plot the graph. Okay. And then get the in intersection between the relationship with the line of equality. So the value is 1.14. Okay. 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 So again, yeah, because we already compare. I guess I've include in the e-learning. Or if I not include, I will upload after yeah, try after this class. Okay. So again, okay, when we because we we analyze by using the Fillenius, and also we analyze using the bishop. So we may use the lowest value. Okay. For this case, the value is 1.14. Okay, and Fillenius value is 0 point something. So we may use the 0 point something as the value for the factor safety. Okay. Okay, so that is for the Dr. Kamarudin example. Okay. So I guess if you look on Dr. Noli, okay, okay, okay. So you I just go one example only. I guess the rest is it is just a repeat process. But it's very difficult to understand because if you are not draw the problem on the graph paper. Okay. So for example, the slice method is the slope with a 4 slice. Okay. So this is the equation that Dr. Noli used. However, he doesn't show the alpha. Okay. How to get the alpha. Okay. So that's why Dr. Kamarin example is very easy to understand. Okay. So alpha, except for the water level. Okay. Okay, so for this case, okay, so this is the example on Dr. Nudi, and then this is the water table. So she used directly the height of the water table without using the flow net approach. Okay. However, it's still same. It's very difficult to understand. Okay, on how to get the alpha. Okay, unless if we refer to Dr. Kamarudin example. Okay. So the last one is the bishop. Okay. For the bishop, okay, I guess it is a similar approach. However, it's very in this case, okay, the soil for the slice number 9, the base for the size number 9 cover 2 type of soil. Okay. So we look how he solved or she solved this kind of problems. Okay. Unless if she explain, okay, on how to include these 2 type of soil for the size number 9, so it will make us easy to understand. Okay. I guess she not explain. Okay. For the size number 9, okay. For the slice number 9, she only mentioned C as 7 and 29, okay, which is, I'm not sure about the soil properties. Okay, C7, 29. Okay. This is 25. Okay, 25, 7. But for the slice number 25, which is not true, okay, because it has 2 different length, which is represents soil number 2 and soil number 1. Okay. So it's not advisable to refer to the example of Dr. Noli. Okay, for if for this for that example. Okay. Okay. So I guess enough for tonight. Okay. Okay. I will try. Okay. Because usually I'm using my data mobile. Normally I need to go to my office to upload it in the YouTube. Okay. Okay, but I will try. Okay. So we stop for tonight class, and then we may continue tomorrow. Okay. I will try to upload the the uh, the tomorrow slide. Okay, as early as I could. Okay, and we meet tomorrow at 8 p.m.